Alright, hello everyone. Today I feel like talking about ref hacking. If you've hung around Neos and Resonite long enough, you've probably heard the term ref hacking, but you may not know what it means. Um, this is a bit of a guide how to get started with ref hacking, what it is, and a few basic things. Essentially, I don't have much of a plan. I've prepared a few little bits, but I don't know what we'll get to because I have no plan. I don't do this kind of thing, so wish me luck, and hopefully this will be helpful. The important thing to get out of the way is the fact that with ref hacking being a bit of a controversial thing, is there is an element of secrecy or I prefer the thinking an open hostility uh, towards ref hacking and people who do ref hacking. If you talk about ref hacking in the Discord, you'll be met with many, many messages just saying, don't use ref hacking, it won't last forever. If it propagates out into other people's inventories, it will be bad, because it will break someday. So you'll be met by a pile of them, and you'll have a few people might look at you twice, being a bit suspicious of you or whatever. It's just nonsense, I find, because some people don't understand it. Some people have only heard that it does bad things. It has very handy applications to automate some things and do things programmatically that you otherwise just cannot do. Yeah. Very handy. For now, what we're going to focus on is entirely the thinking of, well, you can use it to do things like put items above the root and do a few not so nice things. We aren't going to do that. We're going to talk about it purely in terms of component access. It's all I really care about. We'll be doing some looking at some custom nodes. We'll be using resources from public folders, namely Tessical's public folder and my own public folder, both of which will be linked in the description. And I might as well just pull up, hammering the point again about people being warning against ref hacking all the time. So we're going to have a quick look at a little snippet from the wiki. So I'm going to go first person mode there. Get this out of the way. This is a little snippet from the wiki. Ref hacking is not supported. Depending on how you utilize it, it may or may not last very long. And what we'll be doing essentially will hopefully be stuff that will be fairly resilient, and the only reason it should break is if they break what's called the primitive member editor, despite there being, I don't see any actual functional reason to break the primitive member editor other than to try and block ref hacking entirely. But I don't know, I'm sure about 20 people in the comments will give out to me for saying that. Or might get some angry messages and private messages. That'd be fun. Feel free to. You know what? If you're going to get angry at me, post in comments below. So put your face to your words instead of hiding in DMs. And just to give like reference to things, this is like the first mention of the phrase ref hacking I can find in the old Neos wiki. And here in May 2021. They're talking about how we advise against such mechanisms, and one day it will break. Yeah, you can see between 2021 and 2025, the wording is the same. Still works though. Right, that aside, let's get to the basics. First and foremost, I'm going to close. I'll leave the camera controls open to the side. Yeah, I don't do this much, so we're going to begin with the basic components in terms of what you need. So here is a box I've set up for some purposes. Boom. So we're going to call this little SOP PME, or primitive member editor. And this as a search, this is using the monkey loaders component search editions, I think it's called, NuGet package, or you can use the cherry pick mod that is a bit more common. Personally, I much prefer this one. Do yourself a favor, get one of the two because remembering where everything is we'd be looking for the primitive member editor. That's in uncategorized, and that thing's incredibly long. Back in 2021, that it's the point that it was pointed out that uncategorized is really big and it should be broken down, and they just said that, and the word from Prime was that when they add a search, they might go in and fix the uncategorized and categorize it a bit better. 2025 now, barely. It is the 1st of January, so barely. That's still not in officially, but thank God we have 2 different mods that do the job. So, we need primitive. It helps if I could spell primitive member editor. Now, it does give a nice little warning here, blah, 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 ref hacking bad, blah, blah, blah. And the main job of the primitive member editor, to at least my understanding, is more so UIX stuff that will then essentially allow people to change certain elements. So, like, if you were to spawn out the video player, and if you look at the URL field, that is basically powered entirely by the primitive member editor, from what I could figure out about it anyway. So, again, like I said, primitive member editor is under uncategorized. So if you are having to go through and look at everything manually, it does actually tell us right here at the very top, uncategorized primitive member editor. We need a text editor to go with our primitive member editor. Editor. So we'll spawn that in. It is a UIX thing, so we do need text editor, and to go with our text editor, we need a text, essentially a text field. So we'd be having a look here for text under UIX graphics. It does come with a rect transform that you don't need, so we'll get rid of that. And the last thing we need is a reference field. Reference field of type world element. The nice thing, I don't know if this is a mod thing or not, but it does actually give me some handy useful things here, or recently used things. But to find the world element itself, you will go in here to custom generic arguments, and you type in capital I, not a lowercase l. I've made that mistake before. World element. So this is our very basic setup in terms of what we need. So again, primitive member editor, text editor, text, and a reference field. So let's hook everything together. So text editor goes into our text editor. Content from our text field goes into text drive. Reference, this thing here, from our reference field. That goes into our target. And there is an option to do this, but you don't really need to do that. And most of the time I don't bother doing that, but for the sake of completeness, there it is. It works fine without it, but the important part to make the last of this work together is we need to access the ID field for different elements we find. So in under path, we just put in ID. This is the basic structure you need for ref hacking. Now, this does lead on to the big question of what exactly is a reference. So we will get into that, I suppose. Maybe visually is the easiest way of doing this. So we'll browse our nodes and we'll get our reference. Again, helps if I can spell. Reference. Reference ID onto references. Let's spawn that out. And already that gives us an iWorld element and a ref ID field that we can have a quick look at. So for the sake of argument, I'm going to pull out I suppose we pull out the We put out the finish handling, why not? And we'll reference finish handling, and we plug that in here, and that's the ID. So again, and then we're going to pull out auto caret color field. And we're going to pull this out, pull this out. Now, magic of ref hacking. All right, there we go. We are pulling out and just to kind of go through that, we aren't sourcing it or referencing it. And when we go ref hacking, we aren't getting the source, we're getting the reference. So this is getting into the territory of, if you're not good at Protoflux, it might be worth looking away. But if we have a quick look at this, we can see these two IDs for two elements that follow each other basically sequentially. Actually, yeah, sequentially, finish handling and autocaret. The two IDs are quite similar. So what this will just get us the reference. It gives us the reference ID, and that's the ID. And we can see it is actually sequential, and we use, and for ref hacking, what we do is we take advantage of that to almost like work backwards. So we take an element we know, we take the difference between 2 points, and we apply that difference to another component, which will then give us a certain field within that component. That will make more sense when we get to it. But that is in essence the roughness of it. Once we have the guesstimated ID, we plug that into the primitive member editor, and that will then populate reference field, iWorld element, with the thing with the field that we have just poked. So, right now, we will ignore this, and what we're going to do is begin with a very, I suppose, simple element of we need to get the ID in a form that is functional. So we will delete all of this, and I'm going to go in here and create two components. Actually, I don't even need two components. I can create a value field. And I'm going to take type, I'm going to take type integer. And I'm going to put in 420, magic funny weed number, why not? So, what we're going to do is essentially ref hack our way into getting this field. It sounds silly, but that's what we're going to start with. We're going to ref hack to get something we already know, and that's just to get you introduced to the concept and the general flow. So we begin by, oops, oh, that's what's going on. We begin by referencing our field, so we plug our field in here. We would then get the reference ID. Boom. And now we have this. This is in what's called hexadecimal, so that's base 16. I forgot the term, I forgot what it's actually referred to, base 16. But in order for us to go ref hacking, what we will actually need to do is cast out the preceding ID and to convert the hexadecimal into base 10 decimal. Sounds a bit weird, but it will make sense in a minute. So, what we're going to do is we're going to get toString. We're going to grab our toString node, and we're going to grab it for type object. Type object, where's type object? Type object, there we go. So we plug that into here, and when we open this out, that gets us the same ID in a string format. Yes, I know. Sounds absolutely miraculous. What we're going to do now is we're going to take out the the preceding ID part of this of the ID that we have from the string. So we're going to use remove string. Oh, sorry, string remove. And we're going to plug our ID in here. So there's the ID as we have it. And there is nothing out because we're not feeding this with any information. So for start index, we're going to put in 2. Oh, my bad. But in 2 for length. I normally use substring. There we go. So string remove, length 2. Normally I use substring, which I usually go into start index. So I might as well, since I mentioned substring, I might as well show you how to do the same thing with substring. Substring, string, string output, start index of 2. Same thing. You get the same output. But commonly you'll see string remove being used. Generally I use substring. So we decided just to go with whatever. So now we have this as a string. Now what we do is we need to get that into what's called a ulong. All our IDs are big enough that we would need a ulong. So we go parse. And now we go parse ulong. Ulong, there we go. Parse that in here. And we pull that out, and it'll be 0 because what we have to tell the parser what exactly we're parsing. So we're going to pull out number style and click the little down arrow here. And we get this. Oh, lovely. Thank you. Turn off snapping. Thank you. So, as I already mentioned, this is a hex number in hexadecimal. So we put in hex number. It gives us all this various options that can highlight. So we just hex number, and then that's our value we pick in the end. Hex number, and then we look at the output. Look at that. It's beautiful. So we destroy this, and we destroy this. Right. So. Oh, no snapping turned off. So what we've done so far, just to go over everything, this is the only part where I'm holding hands here, really. We're taking a reference to a field we know. We're getting the reference ID. We're casting that to a string. We're taking out the preceding ID, and we're converting then the actual ID to a ulong, this value here. Now, because we're going to start pumping this back into our primitive member editor, we need to write to the content field. Our content field is of type string. Oops. So we have to cast our ulong, our already generated ulong, back to a string. So a very easy way of getting that back is we go back to our toString. We click that out, pull up our ulong, and we pull this out again, and now we have our ID, the same ID, in type string. Right. So now we pull out our write node. Actions write, value write. And I'm just going to pull out, I know it's an object, but we'll just pull that in here like that. Pull this in here like this. There we go. Come on. Oh. Plug that in there like that. And now, if we watch our reference field right here, when I click call, that will populate. value on value field on box. So we're going to pull this out and we're going to source it. So we pull this out and it says 420, but that is, it's not the actual value that we can cast directly back into an integer. This is just giving us a reference to the actual source. We want to use the actual value for something. So this is where we get into the part of reading and writing. So we might as well cover writing first. I think it's a little bit easier. And then we're going to cover reading. Writing is handy. We just use an indirect write. We use an indirect write. Value indirect write of type integer. There we go. So now we take our, I always forget the order of this terminology. Field as variable. Field as variable. Int. Right. That takes an I value, and we're going to put this in here. Yep. We pull out the I value. It's just this 120. That's how we know the casting worked. We plug that into our variable. And we're going to change the value in our field. So open up our field here. We're going to change that back to something like 69,420. I'm going to add a little bit of fun to the variable. So we pull out our onWritten, we pull out our onFail, and we hit call. Our call is successful, and our value has been updated. And you see that has not been updated because it's only a reference, so it's not going to continuously update. We need to force an update by pulling out the display again. So that's how you would write to a field that you've found. And this is just a primitive field. So, and by primitive, I mean, it's a primitive type. It's not an object type. It's an integer. It's not like it is an actual object that we'd have to set up. We can try getting into that at some point as well. So I'm going to section this part off. Just section this part off. I'm going to section that up here. Now we're going to get into reading. The reading of a primitive is a bit fun because we actually do need components. So I'm going to create a new slot in here under our purple box. And I'm going to call it just look. Again, a perfect spell. Look up. To get this working, what we'll need is a value field of the same type we're trying to read, in this case an integer. Value field int. And we need a value driver, not a value copy. I've made that mistake before and got confused. We need a value driver of type int. So, oh, my nose. So, we take our value and we plug it in here to our drive target. And we can pull out our value, source it. I want to make this screen a bit bigger. And what we'll do now is make it another write. And we're going to write our world element to our value source here. So reference source our value source here. Every now and again I get a little lost between referencing and not referencing, so sorry if I pause from time to time. And we're going to reference out our value field again, our reference field here again, so we're going to source that. Right now that's 0, and if we hook this up here, Yep, that gives us a I value integer. And plug this on, and we hit write. Now we can read the variable. Because what we've essentially done is we have driven, written our source as the original reference, which is the value on value field 1, which is here under box, and this is our resulting field that then we can just source and read normally. So that is a very basic write, read, find. And now if I go in here and I change this to something like 888888, you can see that updates because we have essentially just dragged the value field from value field into here. Essentially all we've done. And that gives us a actual functional thing. So again, we'll pick our indirect write to change our value back, and we've changed our value back. That is a bit of a roundabout way of doing things. But that is the whole hog simplistic example of ref hacking. But you may have noticed that we've started with a field we know, and we went off to find that same field. And another thing you may have noticed is I began by saying we'd be looking at custom nodes. So let's get into the custom nodes first. I have scaling turned on. So let's get into the custom nodes. Now, I have sectioned everything off for a reason, and I'm going to make the screen a bit bigger so we can really have a bit of fun. This is reading. This is writing. So now we pull out our Tesla coil folder. We go in here to custom nodes. We go in here to the ref hacking nodes. And in here is this little thing. This takes an iWorld element and gives us a ulong ref ID. So this comment dot. This node is all of these nodes compressed in together. And just to prove the point, I'm going to take our the reference to our world element, plug that in here, pull this out, pull out our manually generated ulong, and you'll see they are the same. So that does simplify things a little bit. Oh, my eyebrows are really unhappy with me today. So now we will get into the we can get into a lookup. That's the word. So that's where this node comes into play. So we pull this node out. And what this is, this node you like, is it is this. What? It is this, right? Comment, spot. It is all of this and the primitive member editor, all of this in together, hooked up and working. So, to prove the point, what we're going to do is we're going to take another write, and we're going to write our looked up iWorld element to a data model store. And we have a no, so we'll take our reference from our other custom node, plug it in here. There's our lookup. There's our onLookup. Unwritten then, so we can see that it gets done. Well, there we go. So, there we go. I'm just going to structure this out a little bit better so things stay some bit neat. And now this is our iWorld element referencing same as this. So if I pull this out, it's the same. So writing is kind of, I actually not sure if there is a handy dandy writer. Just there. Let's just have a quick look in here now, just be safe. No. So you can see what's involved in writing. Field as variable, int, you have to know your types you're looking for. So here we go again. So what I'm going to do is I'm going to take this, plug that in here, change the number we're writing to again to 999, hit call, and it got updated. This is just, there we go. And that got updated here. So if we go back here to our child, there is our value field that we referenced originally, value 999. So there we go. And now for the reader, there is components involved in the reading, and there is a little bit of Flux involved in the reading. So what I decided to do is under my own folder that you'll find in my public folder, under ref hacking, under value IO, under primitive readers, are a bunch of readers that I spent a little too long making. So I'm going to pull out the read integer, which is this. And I'm going to take our value here, plug this in, and again, I'm going to hook up a write. And hit call. There we go, missed it the first time. And it has now pulled that up. There is a bit of a difference between using this, my little custom node here, versus doing it with this way, with the components. And that is actually a bit of a hindrance. So if we update this number again, well, it could be a bit of a hindrance depending on how you want to implement everything. So we set this back to 420, and I'll hit call. That updated, but that did not. We would have to hit call again to get an updated value. So that is a very basic example setup with some advantages. So we're going to hook up, for fun, I'm just going to hook up our custom nodes and just set it up as something different. Plug this up. This is this. This is this. Duplicate. Cut. Oops. Come on. There we go. Sorry if moving around makes you motion sick at all. I'm very much in the habit of doing it. I will try my best not to do it too much. I don't know why I deleted that. I actually need that. Right. So, in essence, those few nodes here accomplish the same as these nodes here and these components here. But if you're setting it up with this, Don't need to look too closely at the components. Makes life a bit easier. That is now a fairly straightforward example of, I suppose, looking things up. It's going to read our integer. This looks it up, and this writes. So what we're going to do is we're going to string everything together and do a write all in. So hook up our indirect write. And I'm going to set this value to 333 and 555. I'm going to pull this over. Look at our box. Value field. I'm going to hit call. 333, 555. And what that has done in one motion is it's looked up the field, pulled up our reference to it with our primitive member editor, and then written a new value to it. That is a really straightforward example, and if you don't mind, I'm going to pause right here because I really need to go to the toilet.
Okay, so here's where I made a mistake. I left Resonite unattended for 5 minutes and it decided to try and screw me over. When you take off the headset, what it does is it goes into desktop mode and it turns off the streaming camera. I didn't actually know this, and I didn't notice this. It doesn't automatically resume the streaming camera when you turn the headset back on. So from here on out, the video I had recorded is a bit shaky, a bit low res. I've had to cut that to chunks of about 15 minutes, stabilize that in Kdenlive. The reason why I had to break it down to chunks of 15 minutes is Kdenlive would crash just if I gave it too much. And so if the framing goes weird every now and again, now you know why. But hopefully the video is still passable and all the information is still there. I kind of liked how the audio sounded in the end, so let's just roll with it. Would have been faster to just re-record it, but yeah, let's just go.
And we're back. All right, that was a much needed pause. So now, we've gone over everything already. We essentially have this field, and what we're doing is finding it again and writing to it. So what we're going to try for fun now is we're going to actually find a field using ref hacking in a more ref hacky way. So for that, we will need more components and more Flux nodes. So let me just get rid of the gizmo in the distance. It's annoying me. We don't need this bottom Flux anymore. So we're going to get rid of it. So bye-bye. Try again at that. Bye-bye. We don't need this primitive member editor anymore because we have one in the custom protoflux node. Get rid of that. And this is our lookup that we were using before that we don't need now either. Destroy that. So what we need to do, and we're going to get back into the references. So I'm going to pull up the reference offset analyzer, which I have right here, offset checker. So it's where things get fun again, and we're going to do a little bit of stuff manually, just so you can have an understanding of what it is. These nodes are lovely, but they tend to hide how it actually works a small bit. So we're going to grab our component in here. We're going to grab our value in here. 768. All right. So in a technical level, when everything that's under, all the fields that are under a component, will follow a certain structure in terms of the reference ID generation. They will all be at least 256 away from one another. The nice thing is, if we duplicate our offset checker, we'll duplicate that. We'll clear this. And I'm going to create another value field. I'm just going to clear it for the sake of completeness. All right, I guess I can just clear it. I'm going to grab our update order. No, I'm going to grab our component. And I'm going to grab our value field. And wouldn't you know, it's the same. The offset is the same in this particular in this case, and basically every case. The difference in the IDs between the actual like component header and the fields in the component are always the same, at least for now. And we can use that to take advantage of how the game actually works and how things work. So what we will do is we're going to create. I'm going to move these out of the way. I'm going to create another slot here. No, oops. Another slot here. I'm going to create another slot here. There we go. Hit the button this time. And I'm going to call it Find Me. And this, I'm going to call this Source. No, I'm going to call it Reference. I even spelled reference right. Hooray. So destroy that. And I'm going to take our value field, enter Find Me, and copy the component. And destroy this component. So now, this value field here is going to act as our reference. We are going to use this. We will know what this is. We know where it is, and all of our references to it will work. This we will find. We will actually read it, and we're going to read a magic number off of it. 1, 2, 3, 4, 5, 6, 7, 8. Definitely not a password I use in throwaway accounts. Anyway. So, what do we know about the field we're trying to find? It is the component type is value field. And we know what slot it's under. That's all we know. So we're going to use this as our reference. Right. So this is where we get into the really fun node in the Tessicoil custom nodes, ref hacking. And we're going to pull out this, the get components loop. This uses what's called a bag editor behind the scenes. I forget the exact type of bag editor that's fed to it that lists out the components, but let's just say setting up a bag editor is a bit of a pain. Actually does require ref hacking to get it to work. And in order then to get it listing out components the way you'd like, it takes a bit of filtering and creativity, shall we say, put it mildly. So, let me make sure I'm recording. I am. I feel like double checking that because I got paranoid all of a sudden. So we're going to we're going to find our get type. Actually, we're not going to find our get type. What we're going to do is reference our value field, reference that. Reference our, this is where naming is unfortunate, or how would I call this? It's a value field in the value field. We'll reference the value in the value field. There we go, reference. So that number, the ID of the value field will be smaller than the field inside of that value field. So what we do is we subtract the smaller from the bigger. And this always flubs me up the first time doing it. So that's our value. That'll have a bigger ID than this one. We're going to grab this, duplicate, bring this up here. And now this is where we have to talk a little bit about what an iWorld element actually is. The iWorld element is basically a reference to what could be anything in the world with you. essentially acting in programming terms as a pointer or as a reference, and it can be null. And it can contain and it can point to nearly any type, and you just have to be mindful of what type you're kind of pointing to for the sake of reading and writing. So we're going to pull this out, and boom, boom, there's our IDs. And we're going to do a value subtract. Value subtract Yulong. There we go. So plug this in here, plug this in here. And if we're lucky, we will get 768. Yeah, 768. That is our difference. And as confirmed by, oops. Thanks. Oh boy. Sometimes I find the snapping on the red print can be a little bit aggressive. So again, we put in that, put that there. I think that's actually the same one, so we'll just clear that. So put that here, put that here. Keep this in mind. This is our offset checker. It's a handy little tool from Neos days, and this is our little built-in calculator. We are going to keep going with the built-in calculator, and we will get into why in a minute once we get so far. Right. So we have and this is our reference component. So we're going to reference the reference component. And we're going to do two get types. Convert this to another. It is of type value field 1 system int 32. Right. That's where it gets particularly fun. So I don't really want to get into the territory of setting up a bag editor and doing a pile filtering. It is a nightmare. Just use this. It's easier. What it will actually do is like every loop, you'll have a start point, you'll have an end point, and then you have an iteration. For every iteration, what you will have is the component coming out. So if we have, we're just going to spam in, if we had, say, 10 components in this loop will run 10 times. Each component will be then spat out by this. It's just how loops work. If you don't understand how loops work, then you probably shouldn't be watching this video. It may not be for you. Value equals. We're going to count on casting here to work a trait. So it's going to be going through every component under the find me slot, which is of value type int. We want to make sure we're grabbing the correct type of component, because if we grab the wrong type of component and then read the address, we could run into crashing errors if we're assuming it is a value field and it's actually something like simple avatar protection or something like that. You don't want to be reading the wrong kinds where possible. It's just a bit safer, a bit easier to make sure you're getting the right type. So plug. So what this would be doing is if the type of component we found from our loop matches our reference component, which is value field integer, then we will continue with an if. So if space low, boom, on component or iteration. And now what we'll have to do is pull this out. No, we don't need that. Sorry. Pull this one out. This is our component. And we need the reference ID. So we're going to duplicate that. Cut this, apply this in here. This should be 0. It is. Right. So, remember what I had said to you already about the ID for the actual component will be smaller than the fields within the component. So we take the difference between the component and the field, which is 768, and we will add that to the ID of the component that we found already using our funny loop here. So we'll do value add. And in case you're wondering, yes, there are custom nodes out there. We will look at custom nodes that make this easier, but we are going to build this manually so you understand what exactly it is we're doing. And hopefully it makes more sense as to why we're doing it this way. So we'll pull out our value add ulong. Plug. Plug. And now we're going to pull out Tesla coils, handy dandy lookup. This. Plug this in. Untrue. Plug this in here. And what this will spit out then from before is our world element. So I'll plug in our world element. Plug in our data model store. Oops. Data model reference store. And we're going to pull out this so we can see if something actually happens. Now, we're going to plug in our find me slot, which is the slot or component that we're looking for is under. Plug that in here. And now we're going to have a quick pause and have a look at what we're doing again. So these all reference our reference component that we know where it is. It's not changing. So we save and respawn. These will all stay functional. We know where these are. And we know what they are as well. So we find under the find me slot, we will iterate through all of the components under the find me slot. When we match with a type that we're looking for, which is the value field integer, then we will continue on. And what we will be doing is we'll be taking its reference ID and adding to it the difference between we'll be adding to it the difference between our own value field and its value entry. And plug that all in then, and we'll add that together to hopefully then grab this value field from our looked up component. So when we hit call, async call, there we go. 1, 2, 3, 4, 5, 6, 7, 8. We found it. That is our value field. What we have right now here is essentially the same thing as if we had grabbed our value and referenced it. It is basically the same thing. But key difference, rather than actually having to go in and grab it, we've grabbed it programmatically, which then can lead to various automations and making life a little bit easier in different regards. So we're going to pull this up. There we go. That is really what ref hacking is used for. We know our component, we know what we're looking for, we know where it is, and we want to read the value off of it. This will essentially allow us to read the value off of it. We can also write to it using the same method outlined here. So just for the fun of it, we'll write to it. Oops. There we go. Plug. And we're going to write the number 777666. And do an indirect write. Call. It is written to it. We pull out our reference again. So the display will update 777666. We go back to the find me value field 777666. Okay. All right. I promise that we can automate a little bit of this. And I do mean that. Well, not automate, sorry. Simplify this a little bit. So I'm going to pull this down. Pull this over. This is the part we're going to have a look at and try and simplify with one of Tessa Coil's nodes, which is going to be look up from offset. This. Boom. So we are getting into the territory of why exactly. So for every single component, so for every single, we're going to talk a little bit about offset since the word offset came in here. So for every single value field component, every single one, the offset between the component and the value is the same. It is 768. That's what it is. So you might be wondering, why are we calculating that offset manually? Why is this taking a reference object and a reference field, and what it has in it is essentially this again? Because we have to take care of the fact that components can update. Components get new fields from time to time. Not super often, but it does happen. The only field I can think of actually offhand is I'll just pull it up in here for fun, is the simple avatar protection. There we go. This little field here, reassign user on package import, that wasn't there in older versions of the game. If you go back to Neos even, this was not there. If that field, I'll just remove this now, remove all instances. If a field gets added between the component and the field of the component, so we add in another field, we'll call it active. Then we now put an active field in every component as well for argument's sake, and is shoved in here before enabled. Then the 768 will actually grab the enabled field instead of the value field, if it grabs anything at all. So that is why we work off the offset every time, because if the component updates, our reference component will update, and our references to the reference component will update and stay valid. So we can rework out the offset from scratch. That helps make things a little bit more resilient. So now we're getting into the territory of lookup from offset. Right. So what we're going to do is remake some of this using this node to simplify the process. We will need the component loop. We will need the reference and type checking. So get type, and we're going to go into our reference component and find our reference component. We're going to reference that. There we go. And we're going to do another, if here. Let me grab it. Thank you. On true, lookup, on component, in here. And now we get to populate this little node. So we're going to pull out our found component. We're going to plug that into our object. This will be the object that we're reading from. We're going to pull out a reference to our component again. So reference. So this is our reference object. We're going to pull out our reference to the value. There we go again. Boom. And now we'll do another write. Sake of completeness, variable, data model store. Pull out the screen so we can have a look at it. Pull out a display so we can see if something's happening. This code is functionally identical to this. This is a small bit easier to set up, but not by a whole load. It does automate things a little bit for you. So now what we're going to do is we're going to plug in our find me field, and we're going to plug on our button to call. So we'll do an impulse. There we go. 777 666. It's found it. Hooray. Right. Now, you may have noticed that we're going to get into the realm of, I'm going to touch a bit on objects, and I'm going to touch a bit on strings. So instead of a value field integer, we're going to use a value field string. And the reason why is because we will actually need to read it differently. For the basic primitives, I'm beginning to forget words now. For the basic primitives, I have a few nodes here to make life a bit easier. I'll show you how to set it up with components. And for things like, if you're doing anything like float threes or whatever, you will have to set those up for yourself, because at least for right now, there we go. I only have the absolute basics: boolean, byte, s byte, short, u short, int, u long, float, double, and decimal. I don't have float 3, for example. I don't have a float 3, for example. One day I might be bothered to add those. Until then, you can either create your own, or you'll have to just read it the same way as before. Objects and strings are a little different. So we're going to talk about a string for now. So we're going to go value field string. Value field string. Oops. This is our reference. We're going to go into find me. We're going to plug this in here, copy component. And what we're going to do is we're going to find this, and I'm going to set a value of I am I'm really messing up here. Wow. I am a string. All right. So, and we're going to use these nodes here to automate a few different things. And there will be more handy dandy nodes to automate things. Don't worry. So, we're going to grab our value field string reference. There we go. We're going to plug that into our types. Plug that in here. And come on, source it again. Value field string, reference again, for this component here. Grab our value field. Reference it again. And now, when I hit call, it'll iterate over all of the components in under find me. I'll just hit that button, get everything a bit more centered. Oh dear. It's going to iterate over all of the components under find me, and when it finds a component type matching what we're looking for, which is value field type string, it will then write that to our data model store here. So hit call. I am string. That's wonderful. So now, in order to read a string, you can actually just cast to string. So we can go over here. I prepared a few of these to make life a bit easier. to string. I'll plug this in here. Pull this out. I am string. That's how you read a string field. Straightforward. There is another note. Handy proto, testicoil, custom, ref hacking, value IO, read string field. You can use this, and we're going to use this to do the same thing as that with the string field. Oh, my nose. Oof. My nose is ticklish. So we're going to do the same thing again of plug in our find me field, plug in our async call button on component. We're going to do an if. I don't know where you got that. That starts, that's iteration. If on true equals type. We're going to go back to our reference and we're going to pull out our reference type component, plug this in here. All right, and now we get to do a little bit of fun of, this is our component that we're reading from. This is a reference to our known components that we know won't change. And just make sure it actually cast okay. It cast okay. Grab a reference now to our value field in under our component. Make sure that cast okay. Null. Yeah, that's right. And now we go right. I absolutely despise having that issue all of the time. Data model store. Plug this out. And there we go. And I'm going to hit async call. I am string. So again, this has simplified some of the code, some of the flux we have. So we went from this, which is already massively simplified because of the get components loop. You can unpack that if you'd like to see how big that is. It is a really big thing. We've simplified that down to this using the lookup from offset, and we then have this. Just simplify things down again for the sake of a string. Right. So we've gone over a primitive, writing and reading. We have gone over strings. Gone over reading. Actually, we might as well do a write. This is very handy if you're only reading it. But for writing to it, I actually think, if I remember right, is there a note for that? Write string field. Yeah, there is actually a note for writing string fields. Nice. But we will still set it up with an indirect write, just for the sake of everything. So I'll pull this out, have a look at it. Oh no, I need to actually generate it properly, don't I? Actions, indirect write. I suppose object, string, one of the few lowercase objects outside of object itself. Now we go, is it field as variable? Oops. Field as variable. There we go. And string. There we are. So we plug that into our variable. We're going to grab we're actually going to grab this data model store. So instead of being up there with this, I'm going to pull down here. I'm going to move this down out of the way since that's all with you. And I'm going to pull this in over here. It's kind of, I'm trying my best to keep things neat, but we are iterating through things. It will kind of get a little messy. And we're going to plug that in. That's our field. And I value string. We have a look at it. It still says I am string. And I'm going to just put in I am also string. You know what? Mixed casing. Why not? It'll annoy somebody. So again, we're going to pull over here to find me. I am a string, and we hit call. I am also a string. Nice. And again, to do the same thing with right string, we're going to do, I'm going to reuse this, make life a little bit easier. Grab our reference component. Grab our reference field. I'm going to grab, I am also a string 2. This is the component we're writing to, so we're going to plug that in here. No, that's messy, so I'm going to plug it in here. And our if, plug that in here. And we're then going to hit call, which is going to do get component and do a lookup to find the component. I'm hitting the point now where I'm starting to run a little low on energy. So under find me, I am also a string. Hit call, I am also string 2. And that just did that with this. I don't know why I didn't do a little pulse there. Let's just try again. Okay, I don't know that one. Might take this node apart at some point just to automate, just to have a look at that, see if that can be fixed, but not right now. Let's see if it's triggering on fail. That'd be funny. Yeah, it is. That's funny. Right. I have no idea why it's doing that. Alright, so we've gone through this for primitives, we've gone through for strings, and now what we're going to do for fun is we're going to use an object. So, the object we're going to use, I am going to, suppose, what will I do? Would it be time to get a fresh red print? Might actually be time to get a fresh red print. Oh yeah, in case you're wondering about these, I put these over here in case I needed them. These are the basic strings. These are the basic nodes to do a bit of ref hacking. These are simplified. These are the primitive readers that I made, and these are some components. We'll even have a look at components for fun while we're here. So I'm going to pull up this. This is our cone. Our cone will play a royalty-free-ish song. These songs are for the sake of the disclosure requirement. I don't know how bothered I can be to put it in the description. If I can be bothered, I will. The Kevin MacLeod and Compotech songs, Past Sadness, Study and Relax. The one that's plugged in here, I believe, is Past Sadness, so I hit play, and our cone will start playing us music. What we're going to do, let's stop. What we're going to do is ref hack in and find what it's playing, and essentially then go in and write it so it'll play a different song. Well, that'd be fun. I'm beginning to think I might start with a fresh red print. So I'm going to pull this over there, and we're going to pull out fresh red print. There we go. Oh, it was getting a bit messy. Might go to it for shortcuts to nodes. I'm going to take a quick drink while I'm here, actually, before we get started. Right. That's better. Needed that. Open inspector. So, what are we looking for? In this case, I've deliberately picked OGGs, make life a little small bit easier. And we have our audio output and our audio clip player. because you're only allowed so many audio outputs per world before the sound system will start essentially shitting the bed. I'm not going to go by the audio output component. I'm actually going to go by audio clip player. And what we're going to do is ref hacking, find this field, the clip, and find what's in it, which is this. Why are we going to do this? Because it's fun. And I can show you something weird that I don't understand. So yeah. Right. So, like with every bit of ref hacking, we need a reference component to start building upon. So, wrong tip. Create new. New 3D model. I like putting things in little 3D models, and we're going to go with a torus. Why not? So our torus is going to contain our reference component, or reference, audio clip layer. So create child. We're going to put in our reference audio clip layer. Audio. Clip. It would help if I could spell. Clip player, or audio clip player. Ta-da. This is our reference component that we will use to calculate our offsets to then go in and find our audio clip player in here under audio. Right. So, again, we'll get out our loop. We will get... Do we need anything else from in here while I'm here? No. Okay. So, audio clip player. Actually, what am I talking about? We do. Look up from offset. And we're also going to have a look at two other nodes that are a bit strange. So, what we're going to do is... Why isn't that working? There we go. We're going to start building our references here. No, we're going to start building our types. Yes. So get type. We have to do our type checking. Very important. Make sure you're always using the correct component. All right, we hook that up. Look up our if space. Loop on component. We'll pass that through when we find the component we actually want. We're going to plug that into our object field. We're going to then reference our original component here. And we're going to, not source, reference. This is our reference object. This is our reference field. There we go. And now what we're going to do is a write. I'm going to pull up a write node. Yeah, I can never be bothered with the typing out the objects for the object write. I just pull out a value write and then plug that in. Generally, you are a little bit better off because if we go into object write here, for example's sake, and I put in an int, we can find an int under object write. Problem is, this doesn't work. If you try to plug anything into it, what'll happen is your tip will break. It's very annoying. So that is why I always go to the value write, and then allow it to cast to an object type, to an object write where it needs to. And it just kind of does that more dynamically. You run into a few less errors. A few, not entirely, but a few. So we're going to straighten that out, make that all nice and neat. And we're going to pull in our, almost forgot to do this, reference our type. Boop, boop. So, yep, Flux engine, Audio clip player. It's that bar. Wonderful. Thanks you for going all the way down there. It was not annoying at all. Pull this out. Pull in our torus. Click, click, click. So. No, I'm putting in the wrong one. Clear that. Pull in our audio from Cone. So this is the slot that we have our audio clip player under. So we'll plug that in. And now what we'll do is we'll hit call. Hit call. There we go. And what do we have? We have something strange. We have an ID. This is where things get strange with like objects like this. So what we actually have is, despite these IDs not matching up, we actually just have the clip field. If we pull out what is in the clip field, that is that ID. But that isn't what we have. We have we essentially have something pointing us to our static audio clip. So then we need to get in and read this. Now, what you can essentially do is look it up again if you wanted to. You would have to do it with ref hacking, and I don't think there is no handy dandy note in the testicle folder for it. But what you would have to do is set up a primitive member editor, set up a toString. So if we grab our object toString from down here, we plug that in, boom, boom. That's our ID, and then we'd have to go in, subtract our ID, convert that to base 10, convert that back to string, write that to a PME, and then we'd actually have a reference to our static audio clip itself. That's one way of doing it. That's one way. Another way actually doesn't make sense to me. I haven't figured out how this works. Maybe somebody else can enlighten me. So, what we do is we create some components, and I'm going to get rid of the gizmo again. What we do is we create a value field, ref ID. We create a reference field, of type iWorldElement. We then create we then add a value copy of type ref ID. Boom. So now we have this structure. Now to hook everything together, we turn on writeback. Our source is going to be this. Might be this. Might be the other way around, actually. I'm not 100%. I think it is... No. Our target... I'm incorrect here. Our target is our value field, and our source is going to be our reference under the reference field iWorldElement. So, here we go. If this doesn't make sense to you... Yeah, so it makes no sense to me either. And it gets worse. It gets significantly more confusing. Because what we will wind up doing is writing this value to itself to populate this. And if you don't believe me, that's what we're going to... I'm going to just do that right now. This still eludes me. So. Oh, my head, what are you doing? All right. So, we grab our value field and we source it. Right? We source it. I'm going to make this a bit bigger, and I'm going to move this a little bit over here so we can focus on what's in front of us. We need To open this, I'm curious now if there's somebody at the door. There is, it's fine. Yeah, there's people. Yeah, okay. We need to then, from the source we've opened, take this. Take our global reference from under the root of that, which is I-value ref ID. We need to source it. Plug that there. We can now close this. So now we take our right and our value variable we're writing to is our pulled out reference, global reference from this. So we plug that in here. Okay. I broke my tip. Hang on. Let's try again. There we go. No, that didn't work. All right. Put auto right. Yeah, if you can't tell, that was mildly annoying. But that's okay. I value ref ID. I'm just going to put it in a float and see if that will just let me squeak on by. It will. So I value ref ID. We take our world element that we've already found. We plug that into here and we cast it. And what happens now is we pull this out and we still have our ID. We pull this up. And now we do another write. Now we take this that we've sourced already. Source it. This is going to be our variable. This is going to be our source, our value. And we plug in the written here. Now we pull out this to say, oh, something has actually happened. And pull out our reference, source our reference from our iWorld element field. Plug this out, and we watch as something that makes no sense to me happen. Call. ID is written in, static audio clip asset, static audio clip. Makes no sense. Still, this makes no sense to me. Okay. So, if anyone can explain this, please do, because I actually do not understand this. I have a bit of an idea that we're just modifying this. We're writing an updated modified value to this, and then we're writing that back to this, which is then doing a weird indirect cast, and then that's then writing back using the value copy to the world element field, and then actually populating that. It feels like we're ref hacking without the PME. It's weird. But there we go. That's how that works. Now, let's get some custom nodes to make life a little bit easier, shall we? No, we won't. No, we won't. For funsies, what we're going to actually do, close this, and I'm going to go in here. Oh, it's getting, my throat is getting very dry, so I might take a break, like a quick 5-minute break in a little bit. I gotta take a drink of water. Right, we're going to pull out pip, source. Oops. This is our reference field. We're just going to prove we can write to it. Here, value. No, sorry. Variable. Now we need to cast between a world element and a I as the provider audio clip. So that's why I have this folder here called hard to spawn. This will actually have the cast right here ready for us to go. So world element and I as the provider audio clip. So we take our reference that we've already found. Value. So we take this here, plug this in here, pull this out. We still have a long list of bullshit. And when I go in here and hit call, it will write the static audio clip that we've looked up from our cone to this. Isn't that fun? It's weird. I don't fully understand it, to be honest. But that is, yeah, that's genuinely how that works. I don't fully get it. So what we've done, a part I don't understand is this part. I don't like it. So what we've done is we've iterated through the components. We found audio clip player. We got a reference to the actual clip field. And we wrote that to iWorld element up here. We've taken this iWorld element, and from that we have read the actual asset that is stored in the clip player slot, in the clip player object. And then we have taken that as a value that we can actually write to a different audio clip player if we want to. Yeah. Hooray. I know it's not quite what we set out to do in the first place, but you know what? Sometimes plans change.
Okay, here's where I made another bit of a mistake. I forgot actually how to write to the field, and I started going down the complete wrong path to do it. So I decided to cut that part out, and we cut back to me realizing I've gone down the wrong path and showing you another way of reading. After I take a break, I will show you again how to write, and this time it'll actually work.
This is throwing me though a small bit. But I think it's just the fact that I'm starting to run out of energy. Well, more than starting to run out of energy. I could probably do with a little break. But before that, what we'll do is we'll have a quick look at testicoils custom nodes. We'll go into the ref hacking nodes. There is actually a write object field and a read object field. Right? But what we'll do as well, on top of all of that, is I will show you a node that I made before I forget about it. Ref hacking, read object field. So instead of having to manually set this up for yourself with weird components that are a little tricky to actually remember, I made this custom node that you may not always need depending on what you're doing. So we're going to hook that up here. This is just to remind us, this is our clip. Oops. This is our clip field. So we're going to plug that in to read the contents of our clip field. I feel like I'm going to be disturbed in a minute. So we come over here, pull this up, pull this up, pull this up, pull this out, hit call. And what? Oh, that's already our static audio clip. I may have written to it already. Hang on. Call to convert that back to, there we go. And now we will hit call here, and we have our static audio clip, and we still have our ID here. I may have accidentally reused. Oh, I'm a silly Billy, aren't I? This did it. I indirectly wrote to that. That's what I done that time. All right, that makes sense now. Oh boy. So that's how you would get the audio clip. Anyway, again, we use our weird object cast. That is hard to cast. It's hard to pull out. Pull that out, and there's our audio clip. You know what? I'm going to take that like 5-minute break, I think. And we are back. So, I really needed that break, and I actually needed to remember how to do the writing. So I had to change this a small bit because I had to go poking at it to try and remind myself how to do this. So let's go again from the top so we know where we are. Exactly, this is not what I'm looking for. This is what I'm looking for. This is also not what I'm looking for. Where the hell is what I'm looking for gone? Is this? Find me. Oh, it's all that stuff over there. Tourist. Ah, there we go. Right. Right. So, audio. We have our audio slot. Using that, we are finding our audio clip player and writing the clip, this slot, into our iWorld element there. So play, call, and we'll just do that. And now when we pull this out, what we have here is an ID that points to the clip that's in here. Now, we have two variants of reading this. So we have this variant using a custom node that I had made, and we have this variant, which uses a little bit of weird logics and a bit of a weird protoflux and some and just weird logic to begin with. But now we get into the writing. The writing, I did have to actually pause and think about it a little bit, and you'll see why I had to do that. So we will need this little node again to cast from iWorld element to iValue ref ID. And now we need to do something kind of cursed, and we need to generate a source. Source. I've hit the point now where certain words are beginning to be meaningless to me. So source, value source of type ref ID. You can just type in ref ID, capital REF, capital ID. Boom. There we go. An empty source. Now we need to open up the source and modify it. So we crack open our source. We go up to our value source here, and you'll see value source ref ID, and our source is null, so we need to actually give it a source. So we go into attach component. We go in here to protoflux. We go in here to a global reference, and you look for global reference type iValue ref ID. So we'll type all that out. iValue ref ID. iValue ref ID. There we go. And now we have this in as a component under here. So we grab our global reference and we throw it in here under our value source. And we source the reference. Wrong tip. Source the reference. There we go. So we dismiss our many gizmos, and I'm hitting the point now where the world is generating a lot of lag, so it's been on for slightly too long, which is any length of time, really. So we grab our reference, we plug that into here, that's our variable. The reference we're writing is actually this reference here. So just for argument's sake here, we'll pull this out, and we'll pull this out. But when I hook this up here, I'm just going to make that a little neater. You see the IDs in here for some reason are the same. They shouldn't be. Oh boy. Oh well. Look, if it breaks, it breaks. It'll be fine, don't worry. So what we now do is, it's where my own testing that those were different values, but you know what? It doesn't matter. It's fine. We'll figure it out as we go. Unwritten, plug it in here. The variable this time is this, so we plug that in there. Now you might be wondering, what in the name of God is the source? Is the value we write in here? So that is where things get really fun. That is we need the reference ID. That's a component. Back a bit more. Reference ID. We grab our reference ID. Plug that in here. And now what we need is the static audio clip that we want to write to the audio player, in which case is this. So we need to somehow source that. So if I open up this, study and relax, we open the inspector. Audio output. Audio clip player, audio asset even. Static audio clip. Can we reference that? We can probably source it too, actually. You know, just for fun, let's source it. Just to keep us on our toes. Why not? If we source it, nothing happens. Isn't that wonderful? So we'll reference it, plug that in, and now we have an ID. That is the ID of this particular static audio clip, which is study and relax. So we'll close that because we don't need that anymore. And where is our, this is it. There we go. And now, if we watch carefully, when I hit, we need a call button to hit in the first place. So how will I actually show you all of this? There we go. We'll show it to you like this. Get right up close. Watch these IDs. And when I hit this button, that ID will change. It changed. Again, this is one of those things of I don't fully understand why it does this. I'm just glad that it does. Okay, well, I kind of do understand why it does this. I just don't like it. Yeah, I just don't really like it. But that's how you change that. And just to prove that the point that it has been changed, I'm going to hit play. The song is different. So, again, for funsies, past sadness, clickety click, I hit play, and this is kind of drony-ish song, or reverbery-ish song, and now I hit call here. That ID has now changed, and I hit play. There we go. That's fun, isn't it? And if by fun, I mean not particularly fun, but you know, it works. That's how you would then look up a clip. This is how you manually look up an audio clip on audio clip layer, find the clip, and then write a new static audio clip to the asset, to the audio clip asset to the clip field of the audio clip player. And then when you hit play, it changes. You could probably use that to mess with people. Wouldn't that be fun? So, now let's get into the simplification. I have been at this now a little while. Let's get into the simplification with these. So, read object field. What this is going to do, what we're going to do, is we're going to grab our audio clip player. This is our reference audio clip player. Just to remind us all, because I was a bit I do have like a cold or something at the moment that I'm also fighting off, so I am extra exhausted. So that is our audio clip reference to our component. That is the reference to our field. And we're going to rebuild all of this. Actually, we'll just rebuild it here. So what I'm going to do before that is move this off to the side. If it'll even let me do that, so I'll delete this because we don't need it anymore. And I will now just take this. Grab all of this. Of course that didn't grab it all, why would it? There we go. Of course I didn't grab it all, why would it? Let's try again. There we go. There, perfect. It's out of the way. I'm hearing a weird banging outside the window. Right, so now we go custom nodes, we go into our ref hacking nodes, we find our components. So we put in our call button. We'll move all this over to the side. Type. Audio clip player. Type. We'll move this further over. We move that down there where it's out of the way because we won't think about it right now. Here is our reference again. I know this is getting a little bit mad, but this is kind of interesting to do, even for me. Not gonna lie at this point. Well, it's not like I lied to you at all, but I make it sound like I've been lying to you this whole bloody time. So we plug this in, plug this in, plug this in, plug this in. Please. There we go. And we grab our audio from the cone. This is our audio slot from our cone. Untrue. This, our audio clip player component. This. Pull this down, pull this down. And what we'll do is write this to a, almost said file, a variable, a data model store. If I could grab it, that'd be a miracle. And hit call. And now we have just the raw static audio clip. So instead of doing this and then doing a read, you can do this, which will do the fetching. This will do the ref hacking, the PME, this will get the slot, and this will then read the clip to find what's in it for you, which is the static audio clip. So that is the static audio clip, which is in the clip right here. So if I pull up, do I have one there? No, I don't. I'm going to just neat that up. There we go. I'm going to go into Proto, my nodes, hard to spawn. Here we go. Plug this in here, plug this out, and we have, there, we have that. Isn't it wonderful? I think if we pull that out again, I'll have static. Yeah, no. Nice. But yeah, that gets us the static audio clip. Hooray. That will, so yeah, again, instead of finding it, reading it, and then modifying it from there, what we're doing is finding it and then actually reading it, finding it and reading it essentially in one node, which simplifies things a bit. So now we get into the write. So if this is confusing, which it is, you can use that. That makes life easier. And then instead of doing this, which actually isn't so bad, because that one I didn't need to do anything weird with components. This one then can write the new static audio clip that we want into the start directly. So again, we'll set this all up from scratch every time. And type audio clip player. Actually, I'll just move this all up a little bit. Duplicate. This is the duplicate. This is the original. Well, it's not actually. But we'll ignore that for now. That doesn't matter right now. Oh my god, my frame rate's gone again. I don't know what's doing this. It might be all the flux in the world. It might be the fact that the world has been on now a little while. It'll just randomly lag out and annoy me. Reference. this in. Audio. There we go. Plug this in. Yeah, things are getting strange because why on earth is that over there? Yeah, I think the game has been on for a little bit too long at this point, which is just not even that long. Maybe, I don't know, 5 hours at this point with a break, which too long if you have a life. But you know, I play Resonite. You probably play Resonite. Lives aren't required. Lives are merely suggestions. So there's the component we're writing to. There is the if check for if we've actually found a component of type audio clip player. We have to plug in our references again, so it can do all the looking up for us. So plug in audio clip player component, plug in audio clip player clip field, and now for the value, what we do is we plug in the this. So I'm gonna just when I grab that, I'll just duplicate this. Duplicate. There we go. I'll just duplicate that. Plug this in over here. That is starting to annoy me, but I need it. So plug this in here. And so we can actually see it in action. I'm going to grab the ref ID. Plug this in here. Plug this in here. Pull out the unwritten. Pull out the on fail because some of them I'll put on fail for some reason. And what we're going to do is have a look. Oh, wait. There it is. It's the same because I've written to it already. Let me just put in the past sadness one again. There we go. Oh yeah. So now, get nice and squared. AC 900 will be changed out with 03D00. And I'm going to pull over the call, bring it over here. So we can see it all change and hit call. And it changed. And it done the unwrite. So now, again, when it plays our happy song. So yeah, that is a little bit more straightforward than finding it, reading it. Sorry, then finding it and then doing this, which weird. So yeah, you can just use the on-object field. Yeah, so this is for more than just the static audio clip, by the way. If that's not obvious already, anything in the inspectors that kind of look like this, where you have a bit of a field that you can put things in and pop out whatever you put in it. This is what you need that for. So it's probably the only way of getting the IDs for materials and stuff as well. Yeah, I've been doing this now a little while now, and I'm beginning to really get tired of it. But I won't let you down. I will do one more thing. I want to do one more thing just for fun, and it will actually be fast. So we'll close these because we're actually done more or less looking at the ref hacking nodes directly. We'll hop into Desicoil, hop into custom nodes, hop into the ref hacking, and have a quick sconce through it. So this and this, these are the same basically, but this one will give you an on start and on end, similar to like a normal loop, as well as an index. That is kind of the big difference there. This is our lookup. We've already looked at that. This is our read and write. Read and write. We get into the component. We'll get into the component. Add and fetch component gets fun. Parse type is a fun node, and I'm not looking at it because I don't really care right now. Lookup field ref this can be kind of handy. So if you know what if you plug in your component and you know what the field you're trying to read is called, you can always try doing this, but this isn't very efficient. This is why I didn't show it to you. So what this will do, Remember back at the very start when we talked about the reference IDs being at least 256 apart from one another? Is the steps going forward will all be multiples of 256. So it'll take the ID of the component you give it, and then start adding on multiples of 256 to try and find a field name that you've already given it. And if it doesn't find anything at the end of all the steps, it'll just spit out a fail. But if it finds something, it'll spit out field reference and on lookup. Sounds nice, and for one-off things, it's fine. But for anything you might be running multiple times or in a bigger loop, just stay away from it. It's not the nicest way of doing it. And we've seen that already. Cool. So, as hinted on earlier, we'll get to the components. We'll do something fun with the components. So I'm going to close this and close this because we're actually done in this area of looking at the various ref hacking nodes that are available to us and the various ref hacking things and tools and stuff. And oh my, the lag spikes are starting to really get bad. Okay, we'll close this. We'll even delete this. We'll delete this. We don't need it anymore. This was an attempt at reminding myself how to do what I had showed you, so we'll get rid of that. We don't need it. We've already been through all of this. This is where we started. We worked our way up. And again, we worked our way up. So, last panel. Last panel of the day. Toilet paper. Not as insane as it sounds. So. Okay. This is where we get into the add component, remove component. And there is also a fetch component by type, which we're not going to do right now. I don't actually really feel like touching that too much. I'll go at it real quick. But don't particularly like it too much. We'll just move on from it. So, add component, remove component, look up components from that are available. Now, here is our beautiful, beautiful shelf of toilet paper. Beautiful shelf of toilet paper. I grab a roll of toilet paper, but I grab the whole shelf. Now, if we take our laser and we laser over it, all our toilet paper has collision set up, ready to go. So, this is kind of set up, but it is to be a representation of something that you actually might bring into the game. You might actually have something you want to bring in, and you want everything on the shelf to be grabbable. I am actually recording, aren't I? I am. I don't know why I got paranoid about that all of a sudden. Anyway, you might bring something into the game, a shelf, a piece of decorative item, or whatever, and you want everything on it to be grabbable. But by default, it doesn't come in with a grabbable. Well, the object root does, thus being able to do this. Now, options available to you to assess this issue and fix this problem is to either go into the, actually I might have it here in my list, go into here and you grab your settable, the component, and you go click, 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 through it all. You can do that if that's what you want to do, if it makes you feel better. Now, if by some reason you had a couple of hundred items maybe, and they're all very small and dainty, do you really want to be going around clicking, oops, do you really want to be going around clicking this 100 times? You really want to go click, 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 click 100 odd times? Sod that. Sod that. No, we're not doing that. Not today. Not ever. Not today, Satan. What we're going to do is we're going to programmatically add the component with Flux. So, in this particular case, what we have is our bookshelf. This is just the lid of the bookshelf. I'll turn that on so you can have a look at it. It's just big and in the way. So, bye-bye. Shelf 1, toilet paper. Shelf 2, more toilet paper. There's all our toilet paper. Right. We click in to our toilet paper. What do we have? We have mesh renderer and mesh collider. So what do we want on it? We want a grabbable. So what we need to do is essentially use this component, which will, you give it a slot and you give it the component string, which we'll get to, of the component you want to add to the slot that you've given. Behind the scenes, what this is actually an inspector, but with a method proxy to the attach component button. So, how do you get the component string? Well, there's two real ways of getting the component string. So I'm going to go in here, I'm going to click attach component, and in this case, the component we want is called grabbable. Grabbable, and it's right there. But we don't want to just click that and add grabbable. What we need to do is highlight the button, open our inspector, and we go down here to button relay, and we have Flux engine, Flux engine.grabbable. So we can pull this out, plug that in there, and that's how you can get a grabbable component. Alternatively, if you don't want to do that, I actually made a little node, this called get component string, that will guess the correct component string. So for this to work, what we have to do is we go into where we already have a grabbable, and we already have one on the root of bookshelf itself, which is this. So I'm going to pull this out and reference it. And I'm going to plug that into here, pull this out, and we have Flux engine grabbable. So we can use that instead, if that's what we choose to do. So I'm going to go with, basically, I'm going to just, you know what, there's no point. I might as well just leave it at this. There's no point in trying to overcomplicate things right now. So what we're going to do is go through this whole process of getting out another fun custom node, async for each child. Or we can do a regular for each child if we'd like to. There is under Tessa Coils, oops, I don't know why I went into my root custom folder. There is actually a for each child that they have, and this split string, but there's mine are a little different. I don't know why the colors in there is bugged out a little bit, but I have the iteration exposed and the option of reverse exposed, so that works a bit nicer to me anyway, for my uses. Deproto. So plug this in here for each child. I'm just going to go with that. So actually, yeah, I forgot to say this is actually a custom node. Just so we're not doing an async thing, I'm going to pull this one up. And I'm going to show you real quick what it's doing of increment, got the I. Increment, value increment, byte. Might as well do byte, doesn't really matter. On iteration, variable, pull out our variable, data model store. So what it's doing is we give it a slot. This is called instance, and what it will do is it'll iterate over every single child in the slot. It doesn't go nested iteration, so it doesn't go in and in and in and in. You need two of these to do that. Two or more. What you need to do then, I'm getting a little lost here. So for each child, the slot with children, you plug that in, and what you can do then is iterate over each child, and each child being spat out by this output here. So there's an unknown amount of children there. This is each iteration. So I hit call 21. There's 21 kids there. Why not? And yeah, that iterates through each slot under that slot. So we will get rid of value increment. We actually don't need that. And for the sake of simplicity, actually right now, we won't use the async, we'll just use the regular synchronous type. So we pull this in. And for each loop iteration, we will add the Flux engine grabbable component to the slot. And we're doing that for shelf 1. I'm going to deselect all real quick, deselect all, and then hit. Actually, what I'll do, open up toilet paper, hit call. Boom. We've added a grabbable component. We've added it programmatically. Isn't that wondrous? So now when I go down to the toilet paper, I pick it up, toilet paper, toilet paper, toilet paper, toilet paper. Wondrous. And now for shelf 2, grab shelf 2, throw it on. Shelf 2, throw it in. There we go. Call. Does the exact same thing. Toilet paper. Toilet paper. Now grab the toilet paper. Really, really straightforward. You even have an undo there, which I actually didn't know about. Isn't that nice? So now we will destroy that. So now we look at remove component. And you can guess what this does. It removes the component. So what we do in this case is we have to use the get components loop, and we need to get a reference to we'd have to do a reference for type checking and all that fun stuff. Everyone loves type checking. So get type, get type, get type. And we're going to go into our reference component, which is going to be our grabbable on the bookshelf itself. So we'll reference that. Pull this out. Plug this in. For extension.grabbable. Plug this in. And then we do a value equals. Plug this in, plug this in, plug this in. Oops, no, that's not an if, but that was an if. If space. Plug this in. So, actually move this down, move this across. It's not a cast. There you go. So, here we are. Get components loop we need to do. Actually, there's just an async call button, isn't there? Sometimes I forget that exists. So I'm going to grab shelf 1, throw that in there, go to toilet paper. There's our grabbable component. So, iterate what this is doing. It's going to go into... No, hang on. Hang on. That's not going to work. I need to do it for each child as well. So let me get out the for each child. For each child. And we're going to start an async task. There we go. You're going to start an async task. We're going to plug our iteration in here. We're going to plug shelf 1 into here because we have to loop over all of the toilet papers. These will be our toilet papers. This will read the slots. This will read the components in under all of our toilet papers. Plug this in here. Plug this in here. So, click. So again, what this is going to do for us is click again. There we go. When we call it, it'll iterate over all of the children of shelf 1, which is all of our toilet papers. It'll plug our toilet papers into our get components loop. Our get components loop will iterate over all of the components in under our toilet papers. And that then, and when we have a match with the grabbable type, it will continue on to delete that component. It's a bit more complicated than just adding it, isn't it? So we'll hit call, and grabbable is gone. We hit so we plug this in here, shelf one, just for funsies. Pull this up. So, whoops, there. Toilet paper. We hit that. Add grabbable. We hit that. Take off grabbable. Add, remove. Add, remove. Add, remove. And to show you, I'm not cheating. It is all of them. Add, remove. And under this one, add, remove. Isn't that easier? Isn't that so much easier? And again, toilet paper 2. Grab shelf 2, plug that in, and we will remove. Ta-da! That's it. Isn't that so much easier? Isn't that so much easier? You can even use it to do fun things. So, like, not necessarily condoning this, but you sort of could if you wanted to do this. So, what you could potentially do is, if you're very paranoid about like the protection of your avatar, you could rig it up so that I'm actually going to move this component in under bookshelf itself. Copy. Put it in under, is it this one? Yeah, I did. Remove single instance. So this is our toilet paper component. Not toilet paper component. This is our simple avatar protection component. And we will reference that. Plug this in here. Plug this out. And we have for extension common avatar, that's simple avatar protection. We plug this into our add component. And now for shelf 1, I'll hit call. Simple avatar protection is my name under all of these things. If you're really paranoid about avatar protection, that is something you can do if you really want to. Now, what you can also do is very easily, anyone can change that. So you can even go further afield if you really wanted. And then for each component, you can find that and effectively then change this field if you wanted to. So for fun, let's try doing that, shall we? Because it's simple avatar protection, and I'm just gonna have to go in and remove all instances, which I think will destroy our original. It does. So for the sake of creating a reference, what I'm going to do, shiver down my spine. I'm going to create a new 3D model. I'm going to create a sphere. And I'm very protective of my sphere, so I'm going to put simple avatar protection on my avatar. Simple avatar protection. Not my avatar, my sphere, my very precious sphere. Grab this. Oops. Grab this. Source this. Oops. Reference this. There's our component again, so that'll live. What? I think it's just bugging out now. It's probably angry at me. There we go. Oh, shivered down my spine there. So now that's where we can actually use the, actually a great example of using the testicle custom node, ref hacking, and this little boy, add and fetch component. So what we're going to do is we'll add the component. When the component is added, we will create a new async task. So you'll have to, that's async. Put this in here, put this in here. Pull this out, come on. Goodness. Component string name. No, we'll not do that. So we'll do this. Child in here. Component string name in here. Component type. Get to type. Grab this. Simple avatar protection. Plug that in here. And that'll find the component. And now what we're going to do is same thing as always before. Click that button to center everything up a bit. Is we are going to essentially do an indirect write to that field. So we're going to do a lookup from offset. Lookup. Component. That's our component. That'll cast away fine. So our reference is this. Reference. Oops. Reference. Our reference field is this. Reference. And that will give us the field then that we will need to manipulate. So now we do an indirect. Indirect, right. Value indirect, Boolean. Now we go field as variable. Field is variable. I always mess that one up. Field as variable. Bool. And we're writing the value false. This is the field. On lookup, plug that in. On written, plug this out, pull this in. And now, with any luck, we won't crash. Oh my god, can I just grab this, please? Thank you. I'm a bit of a neat freak, even though I didn't make it much neater. So now what we're going to do is under shelf 1, we'll go into toilet paper. For every single slot of this, what we're going to do is inject simple avatar protection. And then once we have injected simple avatar protection, we will be going in and resetting this value because anyone can actually just go in and reset that value. Hit call. There we go. Ta-da! Did it. We go in under here. It did it. It did it. It's not as weird as it seems. So now there is the what is the there's one I had to show somebody. The constant character force. Is that it? Constant character controller modifier? Character. Is that it? Might have been this. I'm not 100%. That's just the word constant was in it. Let me just flick through this. Yeah, I guess it was that. I guess it was this component for somebody. Again, same thing. It defaults in as 0, so I'm going to move this over here. Copy. Delete that. And what we're going to do is similar thing again of reference. Reference our object. Reference our field. We're not doing that. We are be doing an indirect write as type float. Yep. Cast and then put that in. No. Yeah. I got the value. Plug that in. There we go. So what the person I remember showing this to was trying to make it so that um, you can go up stairs easier. So they were putting on mesh surfaces of stairs to make the life a bit easier. And there was a map they were working on, and there was several sets of stairs, and they wanted a way of automating applying the component to the stair meshes. Thankfully, they were all together, and then write a default value of something like 999, or in this case 100. So we're going to source this again. Sorry, no source reference this again. So plug this in here. This is our object. There we go. Plug this in here. That's our type. And now, under shelf 1, it will inject a constant character controller modifier and set the value to 100. Cool. Ta-da! Isn't that a nice culmination of like everything we've gone through today? Oh boy, we've been at this now. I don't know how long anymore. I am thoroughly tired. But what we will, one last little thing I'll give you is say in particular to value field. Value field type string. So now you have two. This has been wonderful in the sense that we have manufactured all of this. We have one. There's only one instance of the same type of component in under the slots that we're poking at. However, in scenarios where you might have multiple of the same types, in this case strings, so we'll call this string 1. Can I click it, please? There we go. String 1. And change this now to string 2. What you'd have to do then when iterating over this is you'll have to look for the one, if you want a specific one to rewrite, say string 2, you will need to actually go in and read the value of the field to see which one you have. So we might as well do that real quick while we're here for fun. I'm just trying to move this up. What am I doing? Can I move this up, please? Thank you. So, components loop. Get components. That's the async call. That's our slot. This is going to be a slot with component, title paper 1. And we're specifically looking for a component. We know the type we're looking for, which is value field. There we go. I'm just going to source this one directly. You know how already we can put in a proper reference that we know about somewhere else, but for the sake of simplicity, let me do a value equals. There we go. I knew I had one. So if value equals that, if what we'll do in this particular case then is we will do a lookup by field. We can also look up the string, but then we'll lose the reference to the actual. Oh yeah, this is a custom node. You can't duplicate custom nodes very easy. You just have to do this. So we cut these. Destroy. This is exhausting. On component lookup, if true. Untrue, lookup. The object we're looking up is our component. The reference is going to be just this. Oops. You know what? Just for the sake of completeness, there we go. We move this over here. Copy. Reference. Duplicate. Reference, plug in. And now we have lookup and field. So now we can go to our previously mentioned toString object here. We go to string, and we're going to look for string 1 actually, because string 1 will be last. So we plug this just straight in because it's a string field. We can just do this. Now we go again, value equals string 1. And now we do an if and a write. Do I have any writes? No, I don't. Actions, right, value right. Plug in, plug this across, variable. You need to do, yeah, so on lookup, plug in here. There we go. And then look up the component, and now we'll do a write. Pull this out here. So what this is going to do is it's going to go into toilet paper 1, this one. It's going to iterate over all of these components. It's going to look for type value field string. We have 2, so that'll be 2 hits here on those. That's this part. Now we want to get a specific one. We want to get the one that says value string, that says string 1. So in that case, then we're going to do a read. So just read it. And if it is what we want it to be, it'll write it then to our data model store here. And with all that, we hit call. String 1, data model store. Not string 2, because if it came through, it does go downward. If we accidentally wrote string 2, it would say string 2 instead of string 1. So that's how you'd have to do things like that. It's not as clean as just having the 1, but if you know what it's going to be, or have a good idea what it's going to be, then you can try going that route. So I think that's basically everything. Oh boy. Yeah. Yeah, no, I've been at this now for, Jesus, 4 hours or something like that. Maybe actually even longer, because I had to get all the prep work done, which was just all of this stuff. Yeah, so that's ref hacking. You can see how useful it really is. If you sat down and watch this whole shindig, oh my god, fair play to you. I know I have a very grating and annoying voice, so don't worry about that. But I hope this was actually useful because this isn't stuff anyone will like show you too easily. Yeah. Um, I hope you find the custom nodes thing useful. If there's enough, I suppose if there's interest there, I can do a thing and showing how to make custom nodes. It's fairly straightforward. But I'm not doing that now. I am too tired and I'm done with this. So, yeah, to close out the video, I suppose I hope you enjoyed it. I hope it was worthwhile. If you're going to just send me hate mail or some bullshit like that, what you do is not description, comments. I might as well even go to first person here. Mirroring off. What do you mean mirroring off? What do you mean mirroring off? What do you mean? What do you mean? What do you mean? No, don't tell me. No. Ugh, okay. Oh, okay. I don't know how that looks. That could all look like complete rubbish. I have no fucking clue. Because apparently mirroring was off this whole time and I did not know. Oh, that's so annoying. Hopefully now it'll be okay. I'll have to have a look at it and see if it's okay. If you're watching this, I suppose I dubbed it to be fine. Right. So signing out. I'm Lime. If you're gonna give me a pile of hatred or whatever, comments in below. Put your face to it. Don't be a coward and just don't be a coward and harass me in DMs or anything. Just, you know. All right. Bye bye. Have fun, everyone. Hope you have fun ref hacking.